So I am going to share some videos with you guys, and hopefully this is going to make sense. I also encourage you to look in your book because the graphics in the book are going to be a lot better than the graphics that I'm going to try to draw for you. So there are 6 examples in this section. Professor Dave, I posted a video, and just be careful. He does the same problem, but he goes from 0 to 1. Just make sure when you integrate, you use 1 to 4, because that's what they ask you to do here. So that'll be good. So make sure you maybe already have that done before you're watching my video. All right, so let's talk about example 2. Find the volume created by rotating f of x is negative x squared plus 4, such as a parabola with a vertex at 4. And we're going to rotate that about the y-axis from 0 to 4. So if you think of this shape over here, rotating around the y-axis, it's going to form this, I mean, it's not really a cone, but it kind of like reminds me of like a silo bin or something like that. So if you think of the disc method, and this is what helps me. Maybe it won't help you, but this helps me. The surface area of a disc. So I know right here it looks like an oval, but that really is a circle. And remember, circles are just pi times r squared, the area of them. Well, the radius is the distance to this curve. And I like to label this too. This curve is negative x squared plus 4. So, but we're going around the y-axis. So it's helpful. All right, I scared myself for a second, but I get it now. So it's helpful if we are going to go across the y-axis. This is something I should point out too. Again, these are just little things I found that have helped me. We're going to integrate this in terms of y because we're going towards the y-axis, or we're rotating around the y-axis. So this function, y equals negative x squared plus 4, is right now in terms of x. So let's just solve for y. Let's just get y by itself. I'm just going to flip the x squared and the y. Does that make sense? So I just added the x squared over and subtracted the y. Then to get x by itself, it would be the square root of negative y plus 4. Okay, so the surface area of this disk is going to be pi times the radius squared. This is the radius. This is like, see how this is the value of x right here? And this is the value of x. So we're going to do pi times x, but it's negative y plus 4 squared. So that's kind of nice. The square is just going to eliminate the square root. So it's pi times negative y plus 4. Now, to find the this volume is going to be what we get when we integrate pi times negative y plus 4 in terms of y, and we're going from 0 to 4 on the y-axis. Does that make sense? Like, that's the part that is enclosed here from 0 to 4. So a trick in integrating is this y, since it doesn't have anything, or sorry, the pi, since it doesn't have anything to do with dy, is helpful just to write it out front. And we're just going to integrate from 0 to 4, negative y plus 4 in terms of dy. So leave the pi out front. And then if we would integrate, this would become y squared, and we would want it to put negative 1/2 in front, plus 4y, and we want to evaluate that from 0 to 4. So we're going to have pi, and then now I'm just going to plug in a 4. So 4 squared is 16, half of 16 is negative 8, plus 4 times 4 is 16, minus, if we plug in zeros, it's just 0. So this is just going to turn into 8 pi, and that is going to be the volume of this 3D shape. Okay, example 3, I think it's easier when we rotate across the x-axis. So it kind of seems like they should have done maybe example 2 after example 3, but that's okay. Find the volume of the solid created by rotating f of x is 1 over x over the x-axis, and we just want to go from 1 to 2. So if I was starting this without the picture already, you know, I would graph 1 over x, but then I would only like kind of highlight it from 1 to 2. And then if you're rotating across the x-axis, it's kind of like you just kind of make a little oval shape here and kind of, you know, just draw it as a 3D shape. Now let's think about one of these discs in here. So again, this is a circle. It's just 3D view. It doesn't really look like a circle. So right here, the radius of the circle is just 1 over x. It's just the function. So that's what we want to use. So the surface area of the disc is pi times r squared. Well, our radius is 1 over x, so it'd be pi times 1 over x squared, which is pi times 1 over x squared. Like that. 1 squared over x squared would just be 1 over x squared. We want to integrate this to find the area from 1 to 2. Again, I'm just going to pull this pi out front. 1 over x squared, do you agree we can write it like this? X to the negative 2 dx. So here's our pi. When we integrate x to the negative 2, 1 higher would be x to the negative 1. And then if you would multiply this negative 1, it'd become negative x to the negative 2. So we want a negative right here. And we want to evaluate this from positive 1 to positive 2. So we have pi, and we're going to multiply it by, okay, let's just kind of plug this in our head. So let's plug a 2 in right here. It become negative 2 to the negative 1. That's like saying negative 1/2. Then you always subtract, and now if we plug a 1 in here, that will become negative 1 over 1. You can try it in a calculator if you want. So this is going to be pi times negative 1/2 plus 1, which is positive 1/2. So our answer is just pi over 2. So the volume of this 3D shape is pi over 2. Okay, I had to find a video online to help me with this, but instead of showing you that video, I'm just going to do this problem with you. So do you agree? We're trying to come up with the volume of a cone. And this point here is just R and H, but this is a line. So this part right here is like y equals mx plus b. But what is our b? Where is the y-intercept? It's 0, so I don't really even need it. And then our slope, remember, is rise over run. So our slope is h over r. So that's the equation of this line right here. H over r times x. That's the equation of this line. We want to rotate this line around the y-axis. So we're going to want to do this in terms of y. Okay, well that's a problem, right? Because right now I'm in terms of x. So I'm just going to rewrite this problem in terms of y. So I'm going to multiply by the reciprocal, r over h times y equals x. Okay, and I'm going to fix that over here. So whenever see how this is spinning around the y-axis? So I tell myself, all right, we're going to integrate in terms of y. You want to have your function in terms of y. So we want to be able to plug this into our integration. Okay, so let's think of what the area of this disc would be. So the surface area of the disc, so this circle right here, okay, the radius is r over h times y. So remember, the surface area is pi times the radius of this squared, which is r over h times y squared. Okay, so we can write that as pi times r squared over h squared times y squared. And we are going to integrate this. Now this is kind of weird because we don't really have many numbers, but we do know it's from 0 to h. If you look here, that's how high we're going. And we're starting right here at this point 0. So we're going to integrate from 0 to h, and we're going to integrate this. Now we're going to do this in terms of y. So the only thing you need to have after the integration symbol is anything dealing with y. So we're going to put y squared here. And this pi r squared over h squared we can put in front. So let's go ahead and integrate y squared. And that's pretty easy. It's just y to the third, 1/3 y to the third. And we're going to evaluate that from 0 to h, and we still are going to multiply by pi r squared over h squared. So if you plug in an h to this, do you agree it becomes 1/3 h to the third? So we're going to have pi r squared over h squared times 1/3 h to the third minus, and if you plug in 0, it's just going to all become 0. Okay, so now when you cancel, we get 1/3. This h squared and this h cubed cancel, right? And we have pi r squared h, and then we know that is the volume of a cone. Okay, so wrap your head around that. If you need to pause it a few times, I had to before it made sense to me. Again, I think these are trickier because we're going around the y-axis. This one, derive the volume of a cylinder. This one wants us to take like this line here, and then if you kept going around the x-axis, you guys can kind of see it would form a cylinder. So we're gonna go across the x-axis. This is a dx problem. All right, the value right here is r, which is like the radius of the cylinder, right? And the length of it is this would be like the height of the cylinder. Can you guys kind of like see that? Evaluate the cylinder. This would be this length here is the height of the cylinder. So to get the volume of a cylinder, what we're going to do is let's look at one of these cross sections here. So the radius here is just y equals okay, I got it. This one's so easy, it's tricky. So this height, this right here is the radius, correct? This length right here is the value of r. That's how high off this is. So the area of this circle is pi times r squared. And we want to integrate this in terms of dx. Well, there's not even an x anywhere in this, which is okay. It's kind of like all you have to do is integrate the number 1. So we're going to take pi r squared. We're going to integrate from 0 to h. Why are we going? Remember, we're going across on the x-axis and we're rotating around that. We want to go from 0 up to the height of our cylinder. So that's where we're going from 0 to h, and we're going to just take the derivative of, or the integral of 1. So it's going to be pi r squared, and then we're going to evaluate x from 0 to h. So do you see how it turns into pi r squared h? Okay, and then Professor Dave's video, he derives the volume of a sphere. Now, when I did my assignment, the assignment is, it did get easier. And then check your answers in the back of the book. That's fine. All your answers are going to be in terms of pi. But these are the problems. But I noticed number 7 and number 9 involved what's called the washer method. So I'm going to add on one more example problem using the washer method. Okay, I wish I could draw better, but I can kind of see it, so I hope you guys can see it too. All right, let's say we have this function y equals that 4th x squared. So it's like a really flat parabola going like this. And y equals negative x squared plus 5 is a parabola upside down that has a vertex at 0, 5. And I also put in here that I only want to include the positive values. That's why I didn't kind of show the other side of our parabolas over here. And we're going to rotate this across the x-axis. So what you kind of have are these is this like cone shape, and then you have this orange cone shape inside, but you want to find the area of, or the volume of what's left. It's kind of like this orange piece is cut out. The reason this is called the washer method is because instead of having like a full circle, it's kind of like you have, if I would draw this flat, you have a washer. So like this orange section is here. It's kind of like a donut, and or you know, those are sometimes called a washer. So if this kind of makes sense, we want to take the area or the volume of all the blue, and we want to subtract out the volume of this orange region. So basically you're going to integrate the blue, and then you're going to subtract and integrate, or subtract the answer of the integration of the orange. So there's a little bit of math involved with that. I'm going to pause this and show some work, and then I'll turn it back on.